In this lecture, we're going to be discussing a new chapter that focuses on further applications of trigonometry. Now, so far we have been looking at right triangle trigonometry, where if we have a right triangle, we can use sine, cosine, or Pythagorean theorem, and so forth to find our missing angles and our missing sides. But what if the triangle is not a right triangle? Well, there are some laws that we can use, in particular laws of sine and cosine, that we can use to help us to solve the triangles. So the first law, or the first set of laws that we're going to be looking at, are the laws of sines. Now, there are some relationship with triangles and their sides that are very important for us to note. So any triangle that is not a right triangle is an oblique triangle. So if you hear me talk about the word oblique, that just basically means that it's not a right triangle. Solving an oblique triangle, when you get a question that says solve the oblique triangle or solve a triangle in general, you're being asked to find the missing angles and the missing sides. Now, the relationships that we may have or come across when solving oblique triangles, you may have what we call the angle-side angle relationship, which means you know the measure of two angles and a side. So if you notice, this is your angle here, and then this is your side, and then this is your angle, hence the angle-side angle relationship. So it must be in this order. We also have the angle-angle-side relationship, where you'll have to have an angle and an angle similar, and then a side that is similar. So here we have angle, angle, and side. Now we also have the side-side angle relationship, where we know two sides and an angle. So previously we had two angles and a side. Now we have two sides. So side, side, angle. And you will have this relationship. So these relationships come in handy when we're solving sometimes. Now, let's say we have this triangle and we are trying to, this oblique triangle in particular, and we are trying to, let's say, solve for the missing sides or angles. How do we go about doing that? Well, one technique that we can do is we can create a height by dropping a vertical line from beta. So, like so. So this becomes our height of our triangle, right? And then this forms a perpendicular, so we have a 90-degree angle here. Now, looking at this, we can think about our relationship. So let's say we want to find sine of gamma. So let's say we want to find sine of gamma. So we know that there's a relationship to find gamma. Sine is going to be opposite over a hypotenuse, which is going to be h divided by a. We can use this to find h, right? So if we wanted to figure out what is h, then we can cross multiply, or we can multiply both sides by a. We'll have a sine alpha. Oh, that's not alpha, that's gamma. That's going to be equal to h. So if we are to evaluate this, then we would be able to find h, what the height of this triangle is. Now, in also doing this, we can solve and come up with these formulas for our triangle. in terms of finding the relationship between each sides. So for instance, if we were to do a sine, and this a sine gamma equals h actually works for all sides. So for instance, we may also solve and see that h is equal to, it depends on how you cut the triangle or how you make the height. You can also make the height this way. You can make the height this way. So because we have so many ways to make the height, I won't go through all of them, but in a similar way to how we derive the sine, we can also derive that h is b using this triangle. I think it would be, okay, we already have a sine alpha. Well, it's okay. But in anyways, we can come up with, if we use the bigger triangle, we'll see that sine of alpha equals hypotenuse my triangles are a little bit different. At any rate, we don't even have to worry about that right here. But as I said, we can do the height in many different ways, but I don't think we need to do all of that tonight. So we'll just, or today rather. So we'll just take it for face value here, but we can come up with different relationships by using different heights for this triangle. Now, let's say we have this triangle here, and it's a little bit different from the one we had before with alpha and so on and so forth. But if we were to using the height method, like so, we would be able to come up with these relationships. And these are what we call the laws of sines and cosine, of sines rather. So basically sine of alpha divided by a, and so this is just a set of ratios that we come up with. If we were to come up with these ratios, it's going to be the same for all sides and angles. So basically sine of alpha is going divided by a is going to be the same ratio of sine of beta divided by b and sine of gamma divided by c. But in the same breath, a divided by sine of alpha is going to be the same ratio of b divided by sine of beta and of c divided by sine of gamma. So let's look at a quick example. Here we want to solve the triangle shown. And so usually when we hear or we're asked to solve the triangle, we're looking for the sides and angles that are missing. So firstly, in this instance, we can figure out what beta is, right? Because we know that angles of a triangle measure 180. So beta is going to be 180 minus 50 plus 30. So that tells us that beta is what? 100 degrees. Now, if we want to find B or C, well, we can utilize our relationship. So we know that sine of, in this case, alpha, and that would be divided by A, right? And so alpha is opposite, so A would be here. Beta is going to be opposite of B, and gamma is going to be opposite of C. So sine of alpha divided by A is the same as sine of beta divided by b. So I can use this information since I know what alpha is and I know what A is. I also know what beta is. Well, then that means I can use this information to solve for b. So sine of alpha, so that means I'm doing sine of 50 degrees divided by 10 is equal to sine of 100 degrees divided by b. If I continue to solve, this becomes b sine of 50 degrees equals 10 times sine of 100. And so divide both sides by sine of 50. And be sure to plug this in your calculator. Well, then we'll get that b is going to be equal to about 12.9. In a similar fashion, we can find c. Sine of 50 divided by a is equal to sine of gamma divided by c, right? And so doing something similar to what we did before, we'll get that c is equal to, a is 10 actually. Okay, so c is going to be equal to, and gamma is 30. So we can plug those in. This is going to be equal to 10 times sine of 30 divided by sine of 50. Using the same method we did here. So then what this means is this is going to be equal to roughly 6.5. Okay, and those are my answers. So I found beta, B, and C. Now, there are quite a different number of possibilities that can happen with our oblique triangle when it comes to side-side angle. For instance, here we can have where A is less than the height of the triangle. So if you note, the height of the triangle is actually this entire thing here, but A is not that entire length, right? A is shorter than that, so A is less than H. A could be equal to H. Here in this triangle, let's call it C, A is greater than H, but it's less than B. Or you can have that A is greater than B. So these are your possibilities that can take place. Dropping this height down and this other side, so dropping this extra triangle down, this gives us a big triangle. I think I said that earlier. And so we have to be careful that we're not using the values for the big triangle for the small one. What do I mean by that? So let's do the same thing here. So if we drop down our height, then we can have an additional side like so. So this, what this does is, this is what's making now our big triangle. This is our big triangle here. And so what we could do is we could label this beta prime, and the big angle is going to be gamma prime. Okay. All right. So with this being said, we know that this is 35 degrees. So this angle here outside, These two angles are actually the same. Okay. All right. So now we could do the same thing we did before to find beta. But we have to be very careful because the beta that we're finding is the beta that's outside here. Okay, which is the same as the beta prime here. So really this is what we're finding. So we have to be very careful. What we just found was not what we thought we found. So for instance, we know that, and we'll just do the same thing. So we have that sine alpha over A equals sine beta, we have beta, yeah, over B. So we know alpha is 35 over 6 equals, we don't know what beta is at this point, 8. Okay, so we know that sine (35) divided by 6 times 8 will give us sine beta. And if we want beta, we do sine inverse of 8 times sine 35 over 6. And then when we plug this into our calculator, of course, we got that 49.9. Again, that's really, it's beta, but it's on the outside and it's beta prime. Okay, so if we want to find the inside piece, okay, let's not get it confused. Let's just call beta here. We're going to call this angle here beta. So let's just say it's beta because these two angles are the same. And so using the fact that beta is 49.9, oops, what's going on here? Right? We can find gamma prime. And that's what we found earlier, which is 180 minus 49.9 plus 35. And that gave us 95.1. But that 95.1 is for gamma prime. Okay. Now, if we wanted to know what gamma was, so notice that gamma is for the smaller interior triangle that we had before. So this angle here, let me just keep this the same, right? So these two are the same size as beta. However, this angle here let's do the one on the inside here first. Well, yeah, we'll need the angle here. So notice that this is 49.9. So if that is 49.9, that means that if you notice, these are angles on a straight line here. These two angles here are angles on a straight line. So that means if we subtract 49.9 from 180, we'll get that this interior angle is actually 130.1. So that would make the smaller angle in here, which is gamma, 14.9. So it's a little bit tricky, but hopefully you guys could follow what I was doing. So now we've filled in the interior portions of this triangle. We can now look at the sides. So we can utilize the fact that C, should we sign here? Okay. We can utilize this fact that C divided by sine of 14.9 should be the same ratio as 6 divided by 30 sine of 35 degrees. Okay, solving this, we would get that C is equal to, so I want you guys to do this. Try it and see if you come up with this. For C, so C is going to be roughly 2.7. But again, we want to be very, very careful because the C that we're looking at right now is the C for this entire space here. But that's not really what we want, right? This is C. Okay, we want the little piece or this. Actually, we did find the small piece because we used the interior. Yes, forgive me. Yes, we did find the small piece because we used the interior angles. So this is actually correct here. Ooh, oops. Alrighty, so yes, this is actually fine. C is 2.7. And the C that we're talking about is for the smaller triangle. But let's say we wanted to find C for the bigger triangle, we could call it C prime. Well, that means that C prime divided by sine, C prime would be the entire piece. Put a prime here. Okay, so C prime would over sine of the big, this is 95.1, because it would be opposite to that, is equal to 6 divided by sine of 35. All right, and so if we were to solve for C prime, we'll get that C prime is roughly 10.4. Okay, so that's how we would solve these type of triangles. But hopefully you don't see a lot of these. But yes. Let's say we want to solve this side-side angle triangle. And to be honest, we can just go straight into our relationships where we know sine of 85 over 12 is going to be equal to sine of beta over 9. And so this means 9 sine 85 okay, we could divide both sides by 12. And if we take the inverse sine of this, and that will give us beta. Okay, and so in this instance, beta is 48 about. All right, so now let's see what else do we need to find. Let's say we need to find A. If we need to find A, oh, we can also find alpha here by doing, this one isn't as complicated as before. Okay, and so the answer here is 46.7. Now, if we wanted to find A, it's really straightforward. You can use the same thing. It's going to be equal to now sine 46.7. We're using alpha divided by A. And if you were to solve this, then A equals 8.8. Oops. All right, so whenever you hear the term complete this triangle, that means you're being asked to solve it all the way. All right, so this we do it the same way, using your relationships with sine. I want to quickly look at the area of an oblique triangle. So of course, we recall that area of a triangle is equal to half base times height. But we don't have that in this case, right? We don't have the base, whatever it is that we, would have needed. So this is going to be equal to 1/2, based on what we looked at previously, A times B sine of gamma. Okay, but we actually have quite a bit of them. These are going to be your area formulas that you may come across. Okay, so very good idea to know these. Now let's say we want to find the area of a triangle with sides A equals 90, B equals 52, and angle Y equals 102. Okay, so again, we know that based on what we just saw, area equals 1/2 A B sine Y. So if we plug in, it's going to become 1/2 A. What is A? So if you look here, oh, it's a different triangle actually. A is 90. Haha. Says it in the problem. All right, so 1/2 90. B is 52. Oh, this was supposed to be a gamma. Oops. Alrighty. And so you're just plugging in because they told us gamma is 102. Okay, plug it in your calculator and you should get this answer here. What about an application problem? Let's do an application problem. So find the altitude. Whenever we talk about altitude, we're talking about height, right, of the aircraft in the problem introduced at the beginning of this section. So round to the nearest tenth. Alrighty, so I have not been rounding to the nearest anything. At any rate, this is the same thing. We have a triangle. Here our height is already drawn for us. So what do we need to do? Well, we need to apply our little law of sine. So sine of, so here we have 145. Is it 145? 30? No. Definitely not. 60. So that means this is 60 degrees. This big piece. No, that's not 60. Let me just punch it in. I think it's 130. Yeah, 130. 15, 35, that's 50. Alrighty, so yes. So the big piece is going to be 130 degrees. And so we can use this to find the missing side. So we know that sine of 130 degrees divided by 20, right? That's going to be equal to sine of 35 divided by A. So we're trying to solve these things, right? So A cross multiply, we'll have A times so if we want to get A by itself, we have to divide both sides. By this beautiful expression here. Okay. Plugging this in your calculator, you should get A equals 14.98. Now, if we wanted to find the height, well, that's what they asked us for. So if we wanted to find the height, sine of 15 degrees, opposite over hypotenuse, so sine of 15 is going to be H, I guess this is H, divided by A. Okay, so sine of 15 equals H divided by A. Oh, we already have that one. H divided by 14.98. All right, and so if you plug this in your calculator and solve for H, you'll get that H is 3.88. Alrighty. All right, well, that concludes the second portion of the video. Be sure to look out for your homework between today and tomorrow. Have a good one, guys.